So, so these are our perfect squares and our perfect cubes. They will help us throughout today, but these are the numbers I would say, like if you wanted to be like really ready and want to make things like a little easier for yourself, memorizing these is probably like the fastest way to go about it. So, oh, 729, thanks, Callie. That's our next one, 9 cubed, all the way up to 10 cubed, which is 1,000. Cool. So we have all of our numbers there, right? All of our numbers there. So for our approximations, right, there are two ways that we can deal with radicals, two ways to deal with radicals. One is an approximation. Approximations include decimals, right? Approximations include decimals. So it's the decimal equivalent of this. So if I need to figure that out, I'm going to go ahead and use my trusty Desmos friend. And I'm going to go ahead and type the square root of 18, not 8, 18. And I'm going to use 3 decimal places to the thousandth. So 4.243, something like that. 4.243. So this is my approximation. It's my decimal equivalent of this number, right? I can do the same thing for each of these. So for this one, I would have 2 square root 125, like so. And I get 22.361. I'm rounding up since I have that 6 and 0 here. And then cube root is a little more hidden on Desmos. If you want to do the cube root, you're first going to type that -3. And then you press the, hold on, let me move these windows out of the way. You press the functions button, and then you go over here to miscellaneous. Miscellaneous has like a bunch of stuff, but you choose this one right here, the end square root, called root of, and it'll allow you to put any number there for the index. In our case, we're using 3. So you're putting 3 and then clicking in here and putting 54. Something like that. Is there a cube root on the calculator? Yes, there is a cube root on the calculator. If you're using a fancy dancy, don't tell the school. If you're using a fancy dancy school calculator, you press the on button. If you're using any kind of TI, you press the on button and then you use the math button. So the math button, which is, I guess I'm probably really small. The math button, which is right here. And then you scroll down to number 4. That's the cube root. And then if you want the other one, it's number 5. So if you have a calculator, that's what you're working with here. Yes. So press that math button. That'll help you with everything. Cool. Okay, so back to this. Approximations are decimals. They're great for many situations. In some situations, I need to know the exact version, right? The exact version. If I am an astronaut and I am trying to like go up into space, I probably don't want to round any of my answers, right? And I don't want any of the mathematicians or like computer scientists who helped to design my mission, I don't want them to use any approximations either. I don't want anything to be approximately correct. I don't want to put approximations with my life, right? I want the exact number, right? So in those situations, what we would have is these radicals, right? Radicals, and I want to leave them in radical form, but I want to simplify them. So you've probably done this before, like many times, and you break it down into like 9 and 2, and then you break 9 into 3 and 3, and then you're like 3, there are 2 pairs of 3, so that 3 can come to the outside and 2 is left over, so that's going to stay to the inside. Does this feel familiar to us? Does this feel familiar? Hopefully. David says yes. Christine and Gally. Yeah, we're feeling familiar. Cool. It looks like a bunch of people blowing up my chat with yes. Okay, so that is one way you can do it. A potentially faster / shortcut way is to think about 18 and to say, okay, which of these square numbers that we are talking about up here divides evenly into 18? Which of them? So it's not going to be the big ones. It's got to be one of these. I know that it's 9, right? I know 9 divides evenly into 18. So I could say, okay, 18 is the product of 9 and 2. I know that the square root of 9 is 3 and 2 is left over. So I have my answer here. So I get the same thing as that up there without having to do so much work. Right? So I can do the exact same thing in a slightly easier way. Right? So let's see that one more time. So with 125, I could break it down. I could say, okay, it's 5 and 25. That 25 is 5 and 5. Say, okay, these are coming over here. So 2 times 5 is 10 with the leftover 5. I could say it is that. Or, right? Or I could say, okay, I have 2 square root 125. I know that that is 25 times 5. The square root of 25 is 5. So I'm going to have 5 times the 2 from before, left with the 5 here. So I have 10 square root 5. This is likely, this process here is likely how your professors will do it in college, right? So I want you to be familiar with what this looks like, right? And sometimes they might not even write this step here. Actually, often, in my case, they didn't even write this step here. They just went straight from this to this because they could do this in their head, right? So that is what we're practicing today, is getting some of that process together. Okay. The reason I had us calculate the decimal equivalents is because I want to show you how you can check that they're the same. So if I know that square root of 18 is this decimal, then I could also type here, okay, 3 square root 2. And I see those decimals are the same, right? Those decimals are the same, so I know that they're the same equation, right? Earlier, I had 2 square root 1 square root. Come on, here we go. We had that as 22.361, and now we're saying, okay, that's the same as 10 square root 5. And I can see those decimals are the same. So the approximation is the same for this original equation and this simplified expression here. So similar to this, similar to square roots, we can also do this with cube roots. So I would say like, okay, 54 is 6 and 9, it's 3 and 2, or 3 and 3. And in this case, I'm looking for 3 of them, right? I need a group of 3. So I see this group here. That 3 is going to meet out with this one. So -9, cube root of 2 was left over. So I have my answer there. If you want to keep doing it this way, you're more than welcome to. If you'd like to think about it more in this direction, we have -3 cube root 54. I know that 54, if I'm looking for one of the cube numbers, I know 54 is 2 times 27. So I have 27 times 2. Cube root of 27 is 3. So that 3 is coming to the outside, meeting up with the -3 here. The cube root of 2 left over. That's going to be -9 cube root 2. -9 cube root 2. So I want that one to look like this. Cool. I want us to spend some time practicing, right? So you'll see on the notes version, let me go grab that for you. On the notes version, you'll see that there are a bunch of practice questions. If you don't have it open, go ahead and check the chat. Right, check the chat. There are 8 questions. I am going to send you into your breakout rooms. I'm going to send you into your breakout rooms right now to work on these questions for the next 5 minutes. And in 5 minutes, I'm going to pull you back at 10:13. I'm going to pull you back and we'll go over any that we have questions. Right? But I want you to work on these 8 questions here for the next 5 minutes in your breakout rooms. So if you already ignored the breakout button, you're going to go to the bottom of your screen where it says like mute and turning on your video and share screen, etc. There should be a button that says breakout room. And then you're going to choose the one that you would like to go into. Go ahead and do that now. Go ahead and jump into those rooms. I'll pull you back in a moment. Did we find the breakout room button? Jump into those breakout rooms. Just the first one. Yeah, for sure. So if I'm thinking about the first one here, I'm thinking, okay, so this is 25 and 5. And then the 25 could be 5. Whoa, that's not 25 and 5. It's 25 and 10, my fault. 25 and 10. The 25 you could break into 5 and 5, and then the 10 could be 5 times 2. I'm looking for a group of 3, so here's my 5. So I'd have 5 and the 2's left over, cube root 2, right? If you were thinking about it in our like slightly new way, you might say, okay, I'm looking for a cube root here. I know this is 125 times 2, and 125, the cube root of that is 5, and then the cube root 2 is left over. So 2 sort of like similar but different ways of thinking about it. Yeah, cool. And then confused on the 192 one, for sure, 192. If you want to break this down, you could say this is 2 and I don't know what that would be. 192 divided by 2. I don't know why I'm using the calculator on the side here, but I am. 96. Yes, 96. And then 96 is 2 and 48. 48 is 6 and 8. 8 is 2 and 4. This is 2 and 2. 6 is 3 and 2. This is why we maybe will be moving away from here. So I have a set of 2's. That 2 is coming to the outside. I have a set of 2's. That 2 is coming to the outside. I have another set of 2's. That's coming to the outside. And then I have that 3 left over. So that's staying inside. So 2 times 2 times 2 is 8 root 3. 8 root 3. If you wanted to do this like in the like fast way, 92, you would need to know that 92 is 64 times 3. And then the square root of 64 is 8, and you have 3 left over. So that's the like quote fast way. Cool. Thanks for those questions from the chat. Sweet. Okay, so what I want for us to take a look at then is I want us to think about this next question, which is like adding and subtracting here, right? Adding and subtracting. So with adding and subtracting, the big idea is that we just need to combine like terms, right? So just like 3x minus 5x plus 7x would be positive 5x, right? Just like that would be positive 5x. The same is true if we're using dogs as our variable, so we'd have 5 dogs. The same is true if we have the square root of 2, square root of 2, and square root of 2. This would be 5 square root 2. We're basically thinking about this as like 3 minus 5 would be negative 2, plus 7 would be positive 5. And the radicand does not change, right? So what is here does not change, just like x does not change, just like dogs does not change, right? The square root of 2 also does not change. So originally, I was going to have us go through and like calculate each of these, right? I think that you all can probably do the calculator portion on your own. So I'm going to have us skip that for now. If you want to see it, it's on the video, so you can check out the video. For now, though, I want us to calculate the exact version of these three here for the remainder of our notes. So I see that these already are like terms, they're like radicals. So I'm just going to say, okay, 3 minus 5, that'd be negative 2, plus 7 will be positive 5 square root 2. That is my final answer for this question, right? This is the exact version, and this the approximate version. Okay. For these here, right, I need to make them like radicals before I can jump into making them, into adding them together. So using my new method, I'm going to say, okay, 50, what's the square number that goes in there? Oh, 25 is the square number that goes in there. 25 times 2. That means that this is 5 radical 2. 5 radical 2, because the square root of 25 is 5. If you want to break it down, feel free to do so. I'm going to do it this way. And then here I need to add that to 3 square root of 8. I'm thinking of a number, a square number that goes into 8, so 4, right? And then also 2. So this square root of 4 is 2 with 2 left over on the inside. There's 2 on the inside, right? So my 25 turned into 5 on the outside with 2 on the inside. And my 4 turned into 2 on the outside with 2 on the inside. Now that they are like radicals, they both have square root 2 here. I could say, okay, 5 plus 2 would be 7. And I still have square root 2. Square root 2. Ah, yes, 3, 3, 3. Thank you, chat. You are helping me. Yes, I just forgot to write it down. So the 3 times the 2, yes. 3 times the 2 would make this a 6. Appreciate you. So these two numbers are going together. My fault. So you should have 6 here. So then what is my answer? It's not 7. What would it be? 11. Yes. Appreciate you all correcting me in the chat. You are absolutely correct. The 3 from the beginning combines with the 2 from the 4 to make 6. Yes, appreciate that. Thank you. Cool. So we'd have 11 square root 2. All right. Whew. Good thing I had you guys checking me. All right. Same thing is happening here. We're just using cube roots, right? In order for me to be able to combine them, they need to have the same index. That's this little number right here, the same index and the same radicand, the same index and the same radicand. So I know they're okay because this has a 3 and that has a 3, but I need to make sure that this radical here and that radical there can be simplified to the same radicand. So if I'm thinking about cube root here, I'm thinking, okay, this is 8 and 2. The cube root of 8 is 2, because 2 times 2 times 2 is 8. And I'm going to bring down that negative 3. I'm not going to forget this time. Bringing down this negative 3. And I have the cube root of 2 left over. So this would be negative 6 cube root 2. What radical or what cube root could I break 54 into? What can I break 54 into in order to get a cube number? I can break it into 9 and 6. Yeah, Brandon, but 9 and 6 are not cube numbers. So I need to think about a cube number that I can break it into. I can break it into 27 and 2. 27 and 2. The reason why is because 27 is 3 times 3 times 3, right? It's a cube number from the beginning. So we have, oh boy, there are my cube numbers. Sorry about that. So we have the 3 and 27. Wait for this to catch up. Sorry about that. So the cube root of 27 would be 3, and that 2 is left over inside. So cube root 2. And adding them together. So I'm adding 3 cube root 2. And then since these are the same, they have the same index of 3, they have the same radicand of 2, then we can add them together and we could get negative 3 radicand or cube root of 2. Like so. Cool. All right. Originally, I had these 4 problems to practice on, right? 4 problems to practice on. I will totally let you practice on them if you would like to, but they are not required for our notes section today. I did want to highlight this last question though. So it's already completed for us. I just want to talk through it really fast. The idea being, so we have our cube roots here, broke down 16 into 8 and 2, that became 2 cube root 2, broke down 54 into 27 and 2, so negative 3 cube root 2, and then 24 broke into 8 and 3, so that became 2 root 3. What I wanted to highlight in this section is that we had a cube root of 2, a cube root of 2, and a cube root of 3. So these first two are like terms, they're like radicals that can be combined together because they both have cube root of 2 there. But cube root of 3 cannot be combined. So in my simplified version is this version here where we have 2 parts, right? We have 2 parts here. Okay. So we have this part with the cube root of 2 and this part with the cube root of 3. Couldn't you do 6 and 4? Okay. Same thing. Yes, same thing. Cool. Okay. For your assignment today, you're going to put in your notes. You have 14 problems here to practice. I know 14 is more problems than we have been doing, but they are shorter problems. Like this first one will take you like 10 seconds. So I want us to get some good practice. The answers here are scrambled. Don't try to do them in order. They won't work. And then you have a quick checkpoint form here. That's a Google form. I think it has 3 questions on it. That's just like an extra ticket type thing. And then you have some challenge extra credit. If you would like to do that, you can. And then you have your feedback box here if you would like to do that. Just so you're aware of like how I'm color coding here. If it's optional or if I'm not gonna grade it, well, I'm not gonna grade it for like regular credit, it's in green. And if it's required, it is in yellow. So required to put in your work for part 1 and required to put in your screenshot for part 2. So those are the 2 pieces and required for your notes. That's the 3 pieces for your assignment today. Are there any questions about the assignment or how we're going to get started today? Any questions? Things we're thinking about? Okay, I would love to do one more last poll before you leave. How are we feeling about this topic as a whole now that we've seen all of those things? How are we feeling about the topic as a whole? Cool. Awesome. Got lots of numbers here. Looking good. Got 81% of people have voted so far. I think we have a few people in breakout rooms, so that makes sense. Cool. Okay, team. That is the end of our time together today. If you don't have Spanish right now and you want to stay and ask a question, you're welcome to. If you have Spanish, feel free to ask me your question after Spanish. Shoot me a text message, send me an email. Happy to help. Otherwise, I will see you all next week. I'll see you next week. Bye.
Bye, Miss. Enjoy the rest of your day.
Bye, Gally. You too. Yeah, Eric, I can. Bye, Kayla. Bye, Diana. Bye, Walter. 1 second, Eric. Let me find it. There you go. Yeah, Christine, totally. Which one do you want to go over?
Number 14.
14? Yeah.
Yeah.
Yep, yeah. Sorry, I disconnected it, but I shouldn't have. How are you today, Christine?
I understand it. The only thing that confused me there was that the square root is 16, so it's a perfect square root. So how would I change that with the stuff outside?
Well, for 14, you have to do a cube root. So even though 16 is a square root, we have to find a cube number that we can take out. So I would say you could use 8 and 2.
Oh, okay. Thank you.
Yeah, no problem. So then you're thinking like, okay, this becomes a 2 on the outside, combining with this 2 that's already there, and then we have this guy like that. So this would end up being like 4 cube root of 2.
Yeah, I got it. Thank you.
Okay. Yeah, no problem. All right. Was that your only question, Christine?
Yeah, it was. Thank you. Bye.
Yeah, no problem. See you later. Cheyenne, are you there?